Alright, then welcome back everyone. Let's solve this question, array merging. So I'll summarize the question for you. The question is pretty simple. You are given two arrays of same length n, and what you want to do is you want to merge it into an array C of length 12. That is, you want to use all the elements of A and B. The way merging works is, they have explained here, is pretty simple. You just successively take the first element, right? First element of either array and append it back of the C. So until both the arrays are empty, you keep on doing the operation, like taking the first element of the array and putting it back of the C. Now, what does this question want? Like, what is the expected output? So input is pretty simple. The length of both the arrays A and B, and the output, what they're asking is maximum length of subarray consisting of equal values across all the merges. So the way the merges work is, we have two arrays A and B, and we are going to successfully take out the first element like this. Now there can be many combinations, right, to perform this merges into this array C. And what they want is, what is the maximum length of subarray consisting of equal values across all the merges. So there can be many merges possible, right? Among them, what merge is gonna give you longest run of equal values, right? So that is a very important observation. What do you want is longest run of equal values, right? Across all the merges, in which merge you will get the longest run of equal values. So this, like, there's not much observation here required, right? So let's just quickly see what is our aim here. We'll go step by step. I'll try to only use examples to verify the trivial things if there are any, but we'll continue our habit of thinking the question in abstract manner. So what is our final aim? We want to try to keep same values together. The same values should be together, right? So as many values are together, it is beneficial to us. Now, how do you approach this question? So first things first, you want the same values to be together. So you want the longest run, like merge in a way that there should be a longest run of equal values. So let's just take an example, like how elements can be present. That here I've taken like general format how our arrays can do. So there can be some run of x here, and that same x can be present here. There can be run of some element z here, but there may not be z present here. There can be some run of y here, some run of y here. So these lengths are not to the scale. So it might happen that the z, the longest chain of the z is so big that even after putting these two x's together, we are better off putting all the z's together. Similarly, so these are the all like a general way of how array can look. Fine. So what do we want? We want to keep the same values together. Now I'll guide you through like what was my approach to this question. So firstly, I thought maybe if we can figure out some two-pointer approach, maybe I can put a pointer here and keep on, like, I was just trying to construct the array C, but it didn't work out. I was not able to quantify the solution very well. So then I dropped that idea. Then since I was not able to think, like I was not able to build a greedy solution like that, what I thought is, let's just think about brute force. Maybe I can get some idea from the brute force to how to optimize it. And turns out it worked out that way. So what is the brute force here? What is the brute force? The brute force is you try to find out longest possible chain for every unique element, right? So brute force, I was just thinking brute force, nothing much. So what can be the brute force here? What can the brute force? Check for every element, for every, I guess I should use my words very cautiously. Check for every unique element, what is the longest chain? What is the length of longest chain you can get? So the longest chain, I mean the longest run of same elements, right? Length of longest chain, right? For every unique element, what is the length of longest chain I can get? Now, there are two parts to this. How to find every unique element? That is very obvious. You can store all the elements of A and B in a set, and you can get all the unique elements. So that was not a big thing. So this thing can be easily figured out. Now, for every unique element, how do you find this length of longest chain is my question to you. How can you find it? For example, here, x's are present in these two parts, but like there can be x's somewhere here itself, right? There can be x's somewhere here itself. So if it is getting difficult for you, consider this example. Let's say I have some 3 ones here, I have 4 ones here, I have 2 ones here and 3 ones here. There can be many more chunks of 1. Now, what is the longest run of ones you can get in array C? So this is obviously array A and this array B. What is the longest run of ones you can get? Now, if you just observe it, you will find out that you can only combine any two chunks. Like one chunk from here and one chunk from here. You won't be able to do more than that. So in other words, what I'm trying to say is you'll be able to match either with this, or the other way would be you'll be able to match this with this. By the nature, the way we are merging is, so if you're still confused, hear me out. How the merging is going to happen is, if you want to combine these guys with these guys, what are you going to do is, you're going to first put all these elements in the back of C, and then you can put this and this, right? If you want to merge this with this, what you're going to do is, you are again going to put out all these elements here, doesn't really matter what they are, then you can put this in this, right? If you want to merge this with this, what you can do is, again similarly, remove all these elements here, remove all these elements here, then remove all these elements here, and then you'll be able to merge these two, right? You'll be able to put all the ones together. So what it says is, you'll be able to pick one of the run from here. So how many unique runs you have, and you will be able to pick one of the runs from here. How out of how many unique runs you have. Now, one obvious thinking is, which one are you going to pick? This one would be the longest one, right? You'll pick the longest run of one from here, and you're going to pick the longest run of one from here. So if this is, let's say, L1, and this is, let's say, L2, the longest chain of ones that you can get is L1 plus L2. I'll repeat myself again. What is L1 and L2? L1 is the longest run of 1 in this array A, and this L2 is longest run of 1 in array B. And what were we after? Effectively, we are after what is the length of longest chain for this one element. It turns out to be longest run of 1 here plus the longest run of 1 in this guy. And this comes from pretty straightforward observation, right? So what is our approach then? Like brute force. We are still at the brute force, guys. Okay, I have not told you the optimized solution. For every unique element, what is the length of longest chain? And unique element we have figured out. You can simply store all the elements in a set. And what is the length of longest chain for every unique element? It is simply L1 plus L2. L1 is longest run of that element is array A, and L2 is length of longest run of element in array B, right? So if I have to concretize it, here is my approach. So our answer basically, what is the longest run of same elements? It is maximum of where X belongs to all the unique elements. X belongs to all the unique elements. AX plus BX. Now I'll define AX plus BX. So what is this AX? This AX is longest consecutive, pardon my handwriting, but yeah, longest consecutive occurrence of X in A. And this BX is longest consecutive occurrence of X in B, right? Fine. So that's our approach. And turns out, if you are very smart, you can implement this brute force in an optimized way. So the constraints are not very big, 10 power 5, right? So you can easily implement, you can see the constraints are 2 into 10 power 5. You can easily implement n log n solution here, and your job will be done. Now, if you have got the logic, like you can try to implement this on your own, but I'm gonna now spill the beans on how to implement this solution. It's pretty simple. Let's just see. But yeah, do try yourself. I guess you have enough about the approach that you can implement this. So weirdly, the brute force that I was thinking turned out to be the optimized solution. So yeah, the approach can be pretty simple. What you can do is you can get a unique element set. I'll just call it E. Okay. Then what you can get is maybe for array A, you can create a map. And what it stores is it stores the element E, and what is the longest run of that element, right? So the value would be what is the longest run of this element in A. And for the same thing you can do for array B. For element E, you can store what is the longest run of this element in array B. And since you have this element, you have this set. This is set, right? The set of all unique elements. What you can do is you can now go through all the elements in E. You can go through all the elements in E and figure out what is the longest chain among all the unique elements, right? So you can do something like this. You can do max of, so maybe you can maintain answer variable here. So answer can start from 1, right? You will have a chain of 1 element anyway. So max of answer, and what is the current longest chain? So what is the longest chain for a given element? We have already figured out. It is simply map of E, map 1 of E plus map 2 of E. So this is the longest run of this element in first array, and this is the longest run of element in second array. Fine. So that is the approach. I hope you have got it. So let's just quickly implement this approach. Okay, guys. Let's just implement the solution. So I've already taken the input n and then on both the arrays. I have also taken the liberty to create the unique element set. There's not much here. Now let's just proceed to the next step. So what is the next step? Find out the longest run of elements in each of the arrays, right? So what is the longest run of element in array A, and what is the longest run element in array B? So for that we'll need two maps here. So I'll just create two maps. Both are int, comma int. So fine. The constraints are that we can take int, right? Now I expect you to understand the constraints well, because this is what I've done in the 800 and 900 dated questions, right? Explaining you what data type to choose based on the constraint. Fine. So we are growing now, right? So I'll not go into every minute detail that I've already discussed. Fine. So first things first, we'll start with the first element. So the longest run of the first element would be right now 1 only, right? Now there is a pretty standard way to find out the longest run of an element. I've also done this again and again. So here's how you can do it. You can simply go through all the elements of an array, and if array of I, so I should probably start it from 1, right? So then if a of I is equal to a of I minus 1, a of I is equal to a of I minus 1, what you can do is an increment the count. So this count basically stores the local length, right? Local maximum length. Else the count restarts if a guy is not equal to the previous, right? And every time what you'll do is you will update the maximum length of array of I, maximum length of maximum length of this element, longest run of this element in array A, right? So mp1 of a of I would be the original value and count. Now the other way might be to update this when you are resetting it, but if you are updating here, then you will have to update it one more time, because at the end, I hope you know this why we have to do it. The implementation part, I guess from now on you would have found your ways to implement this, right? So I'll not go too deep into it. Fine. Now we want to find the longest run of every element in secondary. So mp2 of b of 0, I'll again start off the same strategy to be 1, and I'll restart my count to be 1. Fine. And then I'll go through this area as well. So the code is pretty much same, so I'll just copy it, right? So it's almost same. I just have to change a to b. So this is pretty much same. Instead of a, I'll have b. So I'll, like, you should not do this in a contest. You should probably type it yourself, otherwise there can be some issues. And yeah, fine. So right now I'll do it, but yeah. So this is doing again the same thing. This is finding out the longest run of an element in array B for every unique element. After we have both the maps ready, now we can go and proceed for a strategy. For every element, we are going to find the longest run. Right? So that's what you're going to do. So I'll initialize my answer to be 1, because the longest run will be by default 1. Even if you have all the unique elements, 2 unique elements are there, the maximum longest run of same elements will be 1. Fine. So answer will be initialized to 1. Then I'll go through all the unique elements. Elements contains all the unique elements. Then we will update answer to max of answer. And what is the longest run of same element? You can get this with this current element. So it will be mp1 of E plus mp2 of E. Fine. So that is fine. That we already discussed. And finally, you can just print the answer. Right. So pretty clean solution, I guess, in my head. So I'll quickly summarize it. So this is the input, and also I've find out all the unique elements. Find out the longest run of every element, every unique element in A. Right. Find out longest run of every unique element in B, and then for every element, find its longest run and take the maximum of it. Fine. So that will be answer. So I'll quickly run it. So 2125 should come, right? Yeah, so there is a stupid typo here. This should be mp1 of A of I, right? The original count, right? So I hope you have noticed it. And this should be mp2 of P of I. This is why you should not copy paste your code. Fine. Let me run it now. Yeah, fine. So 2125. I hope this works. Let me just quickly submit it. Yes, so it works. Thank you for watching. I'll see you in the next one.